Hi folks, welcome to 8.2, the law of cosines. In this video, we're going to take a look at what the law of cosines is. And if you haven't watched 8.1 yet, where we talk about the law of sines, you should definitely do that first. But let's start off with what we know. All right, so we've already talked about this in 8.1, but we know a lot of things about right triangles. We know that sine is the opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. We also know our fabulous Pythagorean theorem, and we know how to find the area of a triangle, but only if it's a right triangle. And so what these two sections, 8.1 and 8.2, are all about is taking a look at things that are for all triangles. All right, so we're in a much more inclusive space now. We're looking at, we've seen the law of sines. Now we're going to be focusing on law of cosines, area of a triangle that doesn't have to be a right triangle. All right, so let's jump right in. All right, law of cosines definition. Okay, so let ABC be any triangle with sides and angles labeled in the usual way, right? So meaning the angles are the capital letters and the lowercase letters are the sides. It turns out that we can find a relationship between the sides and the angles with any one of these three, okay? So I just want to focus on the first one for right now, all right? So let's say that we draw ourselves a triangle, a non-right triangle, okay? And we've got A, we've got B, we've got C, all right? Then little a is here, little b is here, little c is here. And if we take A and we square it, okay, we get A squared. Turns out that A squared is going to equal B squared plus C squared, kind of like the Pythagorean theorem, but minus 2BC cosine A. All right, 2 times B times cosine of A. All right. And so in this equation, if we have A and B and C and angle A, all right, we can usually use this to either find side A or angle A. All right. Now, just like the law of cosine sort of had three ratios set equal to each other, we have three variations of this law of cosines. So if we want to find little b or capital B, we can use the second equation. And if we want little c or capital C, we can use the third equation, okay? Just keep in mind that you've got your angles, and you've got your sides. All right, so you've got sides and angles, and it's really important that we keep track of the uppercase letters versus the lowercase letters. Okay, so let's go ahead and get started. All right, so law of sines versus law of cosines. All right, I think one of the most confusing things in math is learning new formulas and then knowing when do you use them and why do you use them. Okay, so just a quick refresher. We used law of sines in three cases where we had angle, angle, side, angle, and side, side, angle, okay? And so if we draw a quick diagram for each one, and I'll probably just copy this diagram for each of the three. We got little a, we've got little b, we've got little c. All right, let's just copy this a few times. All right, so keeping in mind, it doesn't quite matter what the triangle looks like, but if we have, what did I use? If we have a side, all right, if we have, let's say this side, and we have these two angles, it would have to be either angle B and angle C. That would be a good example of angle, angle, side, okay? Or we could do something like this. That would also be angle, angle, side, okay? So let's say we chose this angle and this angle, then we could choose the side little a, that would be angle, angle, side, okay? But the thing we want to keep in mind is that the side is not the one in between the two angles, all right? Whereas in the second case, we have an angle, and the side in between them, okay? So that might be something like we have, we have this angle C and angle B, then we would have to know angle A, which is, or side A, which is the side in between those two, okay? Or we could have this angle, and then we would have to have side C, all right? So let's just color that in. All right, and last but not least, we had the one that was sort of our ambiguous case, okay? Meaning that we might have 0, 1, or 2 triangles, and we weren't really sure until we took a look at whether we had an angle and the two sides, so maybe C and A, right? Or maybe we have angle A and B and A, the sides, all right? So this should give us a pretty good visual of when we use which case, but let's take a look at law of cosine, okay? So law of cosine. We've drawn ourselves a triangle again. This time, we're gonna be looking at using this law of cosines when we have the following information. Oops. Okay, so let's just duplicate this real quick. Okay, so if we have all three sides, we don't have any angles, but we know side A, side B, and side C, that is a dead giveaway that we want to use law of cosine. Okay. The second case that we'll take a look at is if you have the side and a side. So let's say we have B and A, and then we have the angle that is in between them. Okay. So it might be side, angle, side, or maybe we have side, angle, side. Okay. But as long as that angle is in between them, then we can use our law of cosine. All right. So let's now jump into the examples. We're going to do one for side, 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 and one for side, angle, side. All right, so side, side, side. Example 1, solve triangle ABC, given that angle or side A is 28 feet, B is 47 feet, and C is 58 feet, all right? And so let's go down here into our answer box and just remind ourselves what we're looking for when we're solving a triangle. We want to find all three angles and all three sides. And we might see here that we have A is 28, B is 47, C is 58. So let's write those down. A is 28 feet, B is 47 feet, and C is 58 feet. Okay. So we have all three sides, but we don't have any angles. Then we're going to want to use law of cosine. All right. But first, let's come up with a diagram. Okay. So triangle. A, B, and C. That means this is 28 feet. That little mark means feet, okay? 47 feet and 58 feet. All right. So it's in general, it is a good rule of thumb to find the largest angle first, okay? So find largest angle. Okay, so find the largest angle. We're going to go ahead and remind ourselves that the largest angle is always opposite the largest side. Okay, that means angle C is the biggest. So I'm going to choose the equation C squared equals A squared plus B squared. minus 2ab cosine c. And now I'm going to fill in all the numbers. So 58 squared equals 28 squared plus 47 squared minus 2 times 28 times 47 times cosine c. Now, as far as the computations go, please listen carefully to what I'm looking for, okay? So we can square the 58, that's no problem. We get 3, 3, 6, 4. Then I want you to take these two and square them and add them. So 28 squared plus 47 squared. We add them, we get 2993. Minus, now we're going to multiply our 2 times 28 times 47. 2 times 28 times 47 gives us 2632 cosine c. Okay. All right. So when you're showing me your computations, please do it this way. All right. Now I'm going to subtract the 2993 to the other side. So 3364 minus 2993 gives me 371. Okay. Equals negative 2632 cosine c. All right, you're going to divide both sides now by the 2632. So cosine c equals negative 371 over 2632. Now you're going to take the inverse cosines. Angle C equals inverse cosine, and you're going to type all of this in so that you get a specific number, an accurate number. So inverse cosine negative 371 divided by 2632, and we get 98.103 degrees. Okay, so we found our largest angle. I'm going to go ahead and write that down here, 98.103 degrees. All right, now we're going to find the second largest angle, okay? Find middle angle or medium angle, okay? And let me go ahead and shrink some of this so that we just leave ourselves enough room. All right, so to find the medium angle, that means now we're finding angle B, all right? Now, we can usually use at this point law of sine. So sine of 98.103 degrees over side C, which is 58, equals sine of B over 47. Okay, we could use law of cosines again, but that ends up being a lot more computation. Okay, so now we're going to cross multiply. We get 58 sine B equals 47 sine of 98.103. And then we're going to type sine B equals 47 times sine 98.103 divided by 58. Now we take the inverse sine. Okay, so angle B equal inverse sine of 47 sine 98.103 divided by 58. And we get 53.346 degrees. Okay. Again, I really want you to show me all of this before you type things in. I think that's going to help with your MyOpenMath to make sure you get the right decimal places. But also shows me that we're able to keep exact values for as long as possible. Okay. Last step, we find the smallest angle. And we're going to find the smallest angle by subtracting all the other angles from 180. Okay, so angle A is 180 minus 98.103 minus 53.346. And that gives us, let's see, 28.551 degree.